Hi, welcome to the EEVblog, an electronics engineering video blog of interest to anyone involved in electronics design. I'm your host, Dave Jones. Hi, it's product teardown time today. Yes, not product review, because I didn't really think it was appropriate to review this particular product, because, quite frankly, it's 27 years old. Older than a lot of you kiddies out there watching. What is it? Well, it's the classic Tandy 100 notebook computer. Woohoo! Check it out. Isn't it sex on a stick? Really? This is the original 1983 Tandy 100, designed and built by Kilohertz in Japan, but Tandy bought the rights to it, and it was phenomenally successful as the Tandy 100 and later the Tandy 102. And it was the last machine, it was the last computer that Bill Gates actually wrote a good lot of the code for. So this has got Bill's code in it, believe it or not. There you go. So I thought we'd take a look at it and see how technology has changed, or see what technology was like back then, the electronics and the design and build quality of the Tandy 100. Now I thought this was a pretty appropriate product because it is essentially the world's first notebook slash laptop computer, and it was phenomenally successful. They sold like over 6 million units of this thing. Unbelievable. It had an unbelievably long life all the way through the 80s and even into the 90s as well. So what are the specs on this bad boy, I hear you ask? Well, it's got an Intel 80C85 processor. That's the CMOS version of the classic 8085. It's got 24 kilobytes, a whopping 24 kilobytes of static RAM memory. That's kilobytes, kiddies, okay? Not megabytes or gigabytes, okay? 24 kilobytes of memory. The processor runs at a scorching 2.4 megahertz. Can you believe it? Megahertz. Woohoo! That's really screaming along. It's got a 240 by 64 mono LCD display that could display 40 characters by 8 lines. It's got an RS-232 interface. It's got a printer interface. It's got a 300 baud modem. That's 300 bits per second, okay? Not megbits per second, that's bits per second, kiddies. It's got a cassette port. It could have external floppy drives as well. I think they stored a whopping like 160 kilobytes or something like that, I'm not sure. It's got a barcode wand interface, and it's got a full-size QWERTY keyboard with excellent tactile feel. And really, it runs from 4 AA batteries in the back, standard AA's, for 20 hours. Can you believe it? It got a 1-month standby on those batteries, and it was instant on, instant off. None of this booting up Windows rubbish, okay? Instant on, instant off. Fantastic. And really, it's no bigger or heavier than today's notebook computers. Fantastic. The one I've got here has got 24 kilobytes of RAM. It is expandable to 32 kilobytes, but this one had a retail price when it launched of $1,400 US. That's $1983. So, well, do the conversion to today's dollars. But yeah, it was an amazing machine for its day, the world's first notebook computer. And you know what we say here on the EEVblog? Don't turn it on, take it apart. I'll just do a quick overview of it here, and here's the power switch on the side here. You switch it on and it's instant on. Check it out, and there it is. It's it does have the Y2K bug, okay, because it only stores the year as 2 digits, but there it is. Copyright Microsoft. Here's the main menu. You can go straight into the basic in here, and there it is. TRS-80 Model 100 software. Copyright. They didn't want to use the whole word copyright because that uses a couple of more bytes of memory. You can't have that. Can't just be pissing away a couple of bytes of memory like that. So copyright 1983 Microsoft. This one's 24 kilobytes, so we've got 21,161 bytes free. And the QWERTY keyboard on it is really just beautiful, and it still works perfectly after 27 years. It's got function keys, it's got caps lock, it's got, you know, it's got everything, kiddies. It's even got cursor keys. Fantastic. It's got a memory power protect switch here, so you can actually protect the memory. You can actually back up the memory and switch it off. It uses 4 AA's down here, just standard AA's, no problems at all. It's got an internal, let's pop this open here, it's got a little expansion port which has a couple of access for the extra ROM modules you can actually plug into it, which is rather neat. It's got a built-in, here it is, it's got a RS-232 port. It's the big old DB25 because they didn't use the DB9s in those days. They had the 25-pin ones, the Centronics printer port, a modem port, a standard. It uses a DIN socket and the cassette interface, which goes to a cassette recorder for storing and loading. Really neat bit of unit. Now, it's got direction and ACP for the modem, answer and originate modes. There they are. This is the barcode wand interface. There it is. It's a D9. And on the side, you've got DC power input, the display contrast. There it is, and the on-off switch, and that's it. Really nice functional unit. Okay, let's crack it open. Now to open it up, there's just 4 screws here, and here. It's got these nice little rubber feet on the bottom, so it sits on the desk nicely. They're threaded machine screw ones into brass inserts, very nice. And then you just pop off a couple of these little clips around the edge here. So let's pop a few of those off, and bingo, here we go. Here it is. Ta-da! And that's the keyboard and LCD, but here's what we want to see. Here's the guts of it. Check it out. Oh, isn't that retro porn for engineers? Oh, brings a tear to the eye. It really does. Now, I'll show you the board closer up later. We'll go through it in detail, but as you can see, it's separated into 2 basic halves here via a standard 0.1-inch ribbon header. Classic. Absolutely classic build, and some standard Molex connectors here going over into, it looks like they're soldered directly onto the keypad board here. The keyboard circuitry, there's the LCD, it's its own separate unit up here with quad flat packs, which we'll go into. And then you've got the main processor board here, which is only a 2-layer job, which is actually quite remarkable to actually get the layout on there. And it's totally old school. It's totally late 70s, early 80s build quality using off-the-shelf parts. I love it. Okay, let's take a look at the main processor board. Here's our classic 80C85 CMOS processor. Here's the 6102 UART chip. You remember back then you had to have a 40-pin dip chip just for the UART. Classic. And the 81C55 PIO chip, which actually interfaced to the micro and allowed you to do the peripheral input and output and all that sort of functionality. Now, here's your RAM modules down here into 8 kilobyte chunks. Now, this is actually quite remarkable because this uses like a hybrid technology, which in its day was pretty novel, because normally you would just put in one of these one of these 28-pin dip style CMOS chips, but they haven't. They've actually gone for this hybrid module which converts the 2 SO package chips into the standard dip configuration, and they've done that 3 times. This one has 24 kilobytes of RAM, and there's the optional 8 kilobytes which you can plug in. And as you can see, there's your main processor crystal over there. They've got some discrete point-to-point wiring going from here over to here. I'm not sure what that's actually for, but look, there's a little bodgy resistor in there in some heat shrink. Check it out. There's actually, it's been heat shrunk and put in there as some sort of, well, it's not the resistor looks like it's probably a mod, but there's but those connectors are there for a reason. And you'll notice everywhere on the board it uses standard 4000 series CMOS devices. You can still buy them today in the same packages, doing the same job, and they're just all over the shop. 4000 series CMOS. There's some TL074 op amps up there which we'll go into, but look at that, 4000 series everywhere you look. They're just all over the place. Now down in this corner over here, check out the real-time clock. There's the 32 kilohertz real-time clock crystal, and they've gunked it in there. They've actually put that that gunk glue. That's not like a battery residue or something like that. It looks pretty ugly, but that's just old-fashioned gunking stuff that they've used to just, you know, pot all the components to hold that crystal in place. And as you can see, they're all standard 4000 series CMOS, but there's your timer chip. There it is. That's your clock timer chip, which is right next to the crystal, but 4000 series CMOS. Again, some standard SIP resistor networks and standard quarter watt axial resistors for everything. I love it. And the bypass caps are all standard disc ceramics. They didn't have, you know, surface mount ceramics back in those days. You used the old dip, the old radial disc type devices. And you've got more 4000 series CMOS. There's your power supply over here. Now take a look at the power supply circuitry all around here, and here's the schematic of it. Look, check it out. How old school is that? All discrete transistor solutions. There's a transformer there. And so they're using this as a switching regulator using discrete parts. I love it. There's a 4A13 down there for the reset. That's part of the reset circuitry, and it's just quite, you know, really old school. Now you would do that with one of those single chip DC to DC converter solutions, of course, but, you know, switching it, you know, a megahertz or something like that, really efficient devices. But back then, that's how they did it. Now, if we hold the board up to the light here, as you can see, it's a double-sided, just a standard double-sided layout. There's no inner power planes in there at all. It's all done as a double-sided layout. Brilliant. My hat's off to presumably the guy. I don't mean to be sexist, but very few women were actually doing stuff like this back then. So it probably would have been a guy at Kiosia who laid out this board. I'm sure he put a lot of pride into it, and just fantastic. I love it. And all this circuitry around here is the modem and the cassette interface up here, because the cassette interface has to handle the modulation and demodulation of the serial tape signal, which went to the cassette tape recorder, and then the modem has to handle the isolation and the regular stuff that a 300 baud modem did. Now, as a comparison, here's one 20 years later. This is from a notebook. This is a pretty much a top of the range modern modem 20 years later. So as you can see, all the isolation, and it has to meet all much stricter requirements these days. There it is up close, much stricter requirements, and as you can see, it's come a long way in 20 years, and this is only 300 bits per second. It's remarkable. But look at the amount of circuitry. There's actually not that much circuitry in there. It looks like it because there's lots of discrete resistors, diodes, the caps and the op amps here and stuff like that, but really ultimately there's not much circuitry in there at all to give you a complete 300 baud modem and serial cassette recording interface. Now, the thing to remember with boards like this, back in early 1980s, you could do 4 and more layer boards, but they were prohibitively expensive for a consumer item like this. So it would have been a major design requirement to fit all this circuitry onto a double-sided, a single double-sided board. Single side load, all axial components, dip, through-hole component circuitry, using off-the-shelf parts, because there's no custom devices on here at all. There's no custom ASICs, not a thing. It's all using off-the-shelf parts. Effectively, anyone could have built this back in 1984 using all these off-the-shelf components. But of course the computer-aided CAD technology wasn't really around back then, or it was, but it wasn't really affordable for the individual to use, not even close like it is these days. And it's just remarkable how they've actually built a mainstream consumer product like this just using all standard off-the-shelf components of the time. You don't see that these days. Very few modern consumer items will be made using just regular off-the-shelf components because you can't meet the form factor requirements, you can't meet the power requirements and all that sort of stuff. It's unthinkable to do an iPhone or something like that using off-the-shelf components these days. And there we have the backup battery for the CMOS memory, so you could actually remove the batteries, you could replace them and it would still retain all of your contents, no problems whatsoever. But as you can see, there's lots of, even 27 years later, all these electrolytic capacitors, none have leaked, none have bulged, nothing like that. They're still all in remarkable condition because they actually made them properly back then, whereas now the market's flooded with one hung low brand, capacitors that fail. Everyone's familiar with failing capacitors in consumer products these days, but this still works perfectly 27 years later, and I'm sure it'll still probably be working in another 20 or 30 years as well. You'll probably be able to switch it, well, I don't know, maybe not. You might have to replace a few caps after 60 odd years, but still, it's in remarkable condition and it still works a treat. I love it. And the other thing to remember with boards and layouts like these double-sided boards spread all over the place. They've got ceramic bypass caps everywhere, but really, layout wasn't critical back then, not even close, because this thing only runs at 2.4 megahertz. You could brutalize the layout back then, have it as big as you want, big inductive traces all over the place, and it really wouldn't matter a rat's ass. The thing would pretty much still work. It's brute force engineering. Now, here's something I find really interesting. This is the LCD display board. Check out how many drivers they need for the 240 by 64 LCD display. There are two things I find remarkable about this. One is that it actually uses quad flat pack technology, which was fairly advanced back then. It was fairly novel, and also, check it out, they've actually flipped these ones up the top, this top row, upside down. It's the same chip, but they've actually done a cutout in the board. They've actually routed out the board. It's been cut out, and they've flipped that chip up, and they've flipped it on its back and soldered it on the underside like that. It's brilliant. It's absolutely brilliant. Why they've done that is because it makes the PCB layout possible using a double-sided board. So if they had to flip these top row of chips up the other way, just like they do with these ones here, then they wouldn't have been able to fit this, well, they would have had a lot harder time fitting this on a double-sided board with routing space and all that sort of stuff. And because they would have had to have a lot more vias up here and all sorts of things. So that was a really novel technique, a novel layout and manufacturing technique to lower your cost. One of the things I found really remarkable about this wasn't so much the computer itself, which is great, but was the documentation that came with it. And the kind of documentation they did back in those days, I'll add a link to the service manual for this thing. It has the complete theory of operation. It's got all the schematics, the bill of materials, the PCB layout, all sorts of stuff. It's all in there, and it was written by people who knew what the hell they were talking about. It was written by the engineers who designed it, most likely, and it's just remarkable documentation. Check it out. So there you go. I hope you enjoyed that trip down electronics and manufacturing and computer memory lane there. I thought that was rather fascinating. Just the construction, the double-sided boards, the all discrete circuitry they did back then, and just designing a real winning product like this that lasted for almost more than a decade in the consumer market. It's really remarkable. You hardly get that these days, but over 6 million units sold, and it was designed to meet and need the world's first notebook computer. Look at it, it's tiny. Really, back considering the computers which were back in those days, and it did its task and did it well. Sure, it's only got, 24 or 32 kilobytes of memory, but hey, it's got a 20-hour battery life from a set of AA's. It lasts a month on standby. Really practical stuff that you're struggling to even get these days. Show me a notebook computer with 20 hours life these days. And really, back then, before the information revolution, all you wanted to do was type a document or something like that. It's not like you could play video games and surf the web. And, well, this did the job and did it perfectly. And you can't type more than 32 kilobytes of stuff in a day, really. So it was remarkably practical. I love it. I wish people had just designed things simplistically like this these days. Bloody iPhones. See you next time.